Hello everyone. Today we'll find the distance of closest approach. So first of all, you should know the what is closest distance of closest approach. So that is the minimum distance up to which an energetic alpha particle traveling directly towards a nucleus can move before coming to rest and then retracing its path is known as distance of approach. So this is we are taking at the new uh, this is the nucleus, and the distance between the alpha particle is incident, and this is the impact parameter, which is the b, and this is the with it striking with the initial velocity, and this is called the distance of approach, okay, from the center to the uh, point, and this is ZD, which is the charge, okay. So from this um, we'll find the distance of closest approach. So let's go. So distance of closest approach, so we should know the force, and the electrostatic force is 1 by 4 pi absolute naught. So here is a q1 and q2, both are identical. So instead of q1 and q2, we can write Ze, that is atomic number, and electron. So here is also the same, by r square. It is the Coulomb force. It is none other than the Coulomb force, which is the electrostatic, okay, electrostatic force. So we know that work done is equal to the potential into charge, okay. So it is a 10th grade formula, you know, v equal to w by q. So here we go. So work done is nothing, just an energy, so half mv square. It is the initial kinetic energy, and we know that the what is v is equal to kq by r, okay. So here is r approach, so we can write it k is what, 1 by 4 pi absolute naught, okay. And while writing as q, we know that the q is Ze, so we'll write the Ze by r, distance of closest approach. This is the distance of closest approach into this charge is the alpha for like helium, okay, for the helium particle, okay. So helium is nothing, just it is it charge has 2e, so we will write the helium charge, okay. And after that we can say that this is nothing, just a kinetic energy, and this is 2Z e square by 4 pi absolute naught r naught. So from here we can say that the r is proportional to the 1 by ke, okay. So this is that's it, and here we can also write it as 2Ze by 4 pi absolute naught ke. So this is the distance of the closest approach, okay. And this is the relation between distance of closest approach and kinetic energy. So thank you. Hello everyone. Today we'll derive the Rydberg formula for hydrogen atom spectrum, okay. So we'll all familiar with this equation, and now we'll solve this topic. Is very crucial for chemistry also and physics also. Like, let's go. So we know that the h nu, that is the hv is equal, that is the Planck constant and frequency, okay, which is equal to the energy initial minus energy final. And what is here is the e is nothing, just from the previous equation we had already know. This is En, okay, this is En is equal to what, let's see, okay. En equal to minus me m e4 power 4 divided by 8 h square absolute naught square and n square. So if we'll take the initial term, it become the in, and if we'll take the final term, it become if. Okay, so there's nothing more about. Now put the value here. Okay, so hv equal to m square m e power 4 divided by at h square absolute naught square, and here is like due to the minus sign this will change. Okay, so 1 by nf minus 1 by ni. Okay, here you can also write the n2 square. Okay, if you take here is a 1, that is a 1 and 1 square. Here we'll take the 2, and this is n2 square. So I'm taking is final. Okay, and f is square minus n and initial. Okay, you can as usual you can take it. We know the speed of light is equal to v, which is the frequency lambda. So here the frequency is equal to lambda by c by lambda. Okay, so put v here. Now like c by lambda is equal to m e4 8 absolute naught square h square, and so and here is like 1 by nf square minus 1 by n square. Okay, so put like cross multiply this only. Okay, so 1 by lambda is equal to m e power 4 8 h is absolute square h square divided by c also. So nf square minus 1 by n square h. Okay, so this is how it looks. Now 1 by lambda is equal to r 1 by nf square. How it's come I will tell you. Okay, so this is the main equation. So what is r? R is this constant number, and while putting all the constant value, like you know the m equal to is the mass of electron, charge of electron, absolute value, Planck constant value, speed of light, you know all these constant term. You will put the constant term, you will get r. This is nothing, just this is the r. Okay, this is the r, this is nothing, just this is a r. Okay, which is the Rydberg constant. Okay, here r is the Rydberg constant, which is equal to the r is equal to the 1.07 into 10 to the power 7 per minute. Okay, this is the value of the Rydberg constant, and this is the formula we'll get. Thank you. Hello everyone, today we'll find the radius in n term and vn term, velocity in vn term, and energy in vnth term, and the time period and the frequency from the Bohr's theory of hydrogen atom. Okay, this is the hydrogen atom, this is the velocity, and this is electron, and this is the nucleus having proton. Okay, and this is the distance, we say this is the radius. Okay, and now we'll find each term one by one. Okay, let's go. So we know that from the electrostatic force, Fn equal to 1 by 4 absolute naught E into E, like Q into Q, so it's like E square by Rn square. Okay, so we know that this is this is a kind of circular motion, so we can also apply like centripetal force. Okay, so what is the centripetal force is F equal to mv square by r. So here we can write mvn square by rn and 1 by 4 pi absolute naught e square by rn square. So from here we can remove one rn and one rn from here, so we have mv square is equal to 1 by 4 absolute naught e square by rn. Okay, and also we know that the angular momentum is like this. Okay, mv, v is like vn and rn, from n is equal to n by 2 nh by 2 pi. Okay, and we have ln and vn square. What we'll do, like we'll find the vn from here. Vn is equal to nh by 2 pi m rn. Okay, so this is our vn, but we need to first find the rn. And how we'll find the rn? So put vn value here in vn square, so we'll get nh by 2 pi m rn is like whole square e by 4 pi absolute naught by rn. And after solving this, we'll get our rn is equal to n square h square absolute naught divided by pi m e square. Here we can find the relation is like r is proportional to n square. Okay, this is our relation between rn and n square. Okay, so it is very clear. We'll find our rn, and now we'll go to find the vn. Okay, so let's find the vn. So for finding vn, we have already vn equal to nh divided by 2 pi m rn. Okay, where it formula comes from? So from here, like from here we can say that this formula is come from. And now what we'll do, we will put the rn value. So rn is equal to n square h square absolute naught divided by pi m e square. Okay, so we put rn values here, so we'll get our vn. So after putting it, we'll have vn equal to e square by 2 h absolute naught n, and we can say that the vn is proportional to 1 by n. This is the formula. This is 2 is very important. When we'll draw the graph, we'll draw as this. Okay, yeah, this is not the exactly one. Like this is the kind of, this is the graph. Okay, this is the graph. This is v and this is n, and from previous graph we should know the rn n graph. Okay, so this we'll draw the graph. The graph is like this extent, and this is n and here is r. Okay, so this is all about, we already find rn and vn. Now we'll find the en. Okay, so en, So finding En will know that En is equal to kinetic energy and potential energy. Okay, so let's go. We know the kinetic energy is half mvn square and 1/4 pi absolute naught, and there is a negative sign of E by Rn. This is how, like we know, work done is equal to VQ. So V is what? 1/4 pi absolute naught Q by R. So Q is nothing, just it is a E by Rn, and we'll take the minus because it is the charge of electron. Q here is the charge of an electron, so that's why we use minus E here. Okay, this is V and this is Q. Let's go. Now solving this problem, we have like mvn square is already have like this. This is like we have the mvn square. We'll put this equation in that. Okay, so let's put the equation. We'll have 1/4 pi absolute naught E square by Rn minus 1/4 absolute naught like E square by Rn. Okay, after solving we'll get minus E square by 8 pi absolute naught Rn. Okay, this is our En, and after putting Rn, we know that the Rn is n square h square absolute naught pi me square. So after putting this here, we will have me square by 8 h square, 8 h square absolute naught n square. So here we can have En is directly inversely proportional to the n square. Okay, this is the main formula. You need to also remember this. Okay, and after putting all this value, like we know the absolute naught. What is absolute naught? Absolute naught is 8.854 into 10 to the power 12. Okay, per Newton per square meter and Coulomb square. Okay, this is a charge square, and m is equal to 9.1 into 10 to the power minus 31 kg. Okay, and E is equal to 1.6 into 10 to the power 19 Coulomb, and H is equal to 6.63 into 10 to the power minus 34 JS. And after putting this value in this equation, we'll get E equal to minus 2.17 into 10 to the power minus 18 divided by 1.6 into 10 to the power 19 n square. And this is in the electron volt, and after we'll solve this, we'll get 13.6, like minus 13.6 n square in EV. So the answer will come, which is in the joule. So we'll converting the joule we need into EV, electron volt. So we need to divide it by 1.6 into 10 to the power minus 19. So finally we'll have our E. Okay, So we already done with rnth, vn and en. Now we'll try to find the t. How we'll find the t? So what is t? T is equal to 2 pi r rn by vn, okay? And we know that the rn is equal to n square h square absolute naught by pi me square, okay? And vn equal to e square by 2h absolute naught n. Putting this here and putting this here, we will have our time period which is proportional to the this, okay? And if you want to find t, then put this value here and this you will get the t, but we'll now only use this proportionality, okay? So and we can also say that frequency, like frequency is what? Frequency is just 1 by tn. Is nothing, just 1 by tn frequency. So we can say that if this is proportional to the n cube, so vn, which is the frequency, is also proportional to the 1 by t, 1 by 3, okay? So this is like frequency, this is like time t. You can easily find by putting all this value. This is nothing a big deal. So finally we find this and this. Thank you everyone. Hello everyone, today we'll find the angular momentum of an electron, okay? So this is the lambda and this is the radius. So we'll find our so this is the diagram how we'll get the our angular momentum. So from the de Broglie hypothesis, so we know that the circumference is the distance, okay? So we can say 2 pi r is equal to the n lambda, okay? And we know that the lambda is equal to h by mv. So put lambda value here, so we'll get the pi r equal to nh by mv. So cross multiply, except r will be stay here, so cross multiply is equal to cross multiply will be mvr and divide 2 pi here, okay? And L, we know that the mvr is L equal to n by 2 pi. So this is the angular momentum. Thank you everyone. Hello everyone, today we'll know the concept of energy in ground state of hydrogenation. So we need to know the kinetic energy and the potential energy, and the energy which is the sum of the kinetic energy and potential energy. So here we'll go, and how this formula is come from the previous Born's theory. This is like mv square. So if we multiply the half here and half here, okay, so this is like we'll get the kinetic energy, okay? So what is kinetic energy? So kinetic energy is like ke is equal to half, this is the half, and 1 by 4 absolute naught, we can say the k, okay? And then it is e square by rn. So we can say this formula is come from there, and potential, we know that the work done will be converted in the potential energy, which is V into Q. This is a 10th grade formula, you should know. And what is V here? V, we know that V is K by E, Ke by R, okay? So K, we know the K value, but we'll put this. And here Q is what? Like Q is the charge of electron. Q is the charge of electron, so will be the minus E. And minus ke square by r. So this equation is come from there. Okay, now you know that's pke and this is the total energy. So we'll compare like kinetic energy and this. So we know potential energy is half k e square by r. Okay, so from here, like, we can say that the k e square by r is equal to the 2ke. So put 2ke instead of ke square by r. So ke square by r. So here will be minus 2 of kinetic energy. Okay, and what about the total energy? So total energy we will write like from put ke here is the kinetic energy half ke square by r, and put this is here in that. So and now the answer will become minus ke square by r upon 2 also, and this will be we can say that this is also an kinetic energy. This is also a kinetic energy ke. Okay, so minus sign, with the minus sign ke. So E equal to minus ke. The total energy is equal to ke minus ke, and potential energy is equal to minus 2 ke. This is the kinetic energy. Okay, so I'm done with this video. Thank you for watching.